Hello, actuaries. In this video, we're going through the June 22nd exam PA. This is a different exam than the past exams. The format no longer has the executive summary, where you used to write the majority of your report on the last question, and this was worth 20 points. Now they've moved to a new format. This is the first sitting under that revised format. As with all of the exams, the SOA says in their solution that the solution provided is just one possible solution. Other options are satisfactory to get full credit. So in this video, we'll also go through some of the alternatives. So here's the project statement. We will skip over this and get right into the business problem. You work at ABC, a Canadian travel insurance provider that sells trip cancellation insurance, which covers prepaid expenses for a trip, flights, hotels, etc., in the event of trip cancellation. The product is increasingly attractive to travelers as the cost of trip increases. So right away, you can notice that you want to be selling insurance. So you don't know whether your goal is to make predictions or rather to just understand the data. You are part of a newly formed predictive modeling team in the marketing department of ABC to help the organization increase sales and profitability at their high-end product, which covers trips with at least $1,000 in covered costs. Recently, your manager recommended using a public data source to help you with overall predictive modeling efforts, the Canadian National Travel Survey. And then there's a footnote, and it says, adapted from Statistics Canada, National Travel Survey 2019. This does not constitute an endorsement by Statistics Canada for this product. A model was built on this data, may help provide insight relevant to the marketing department regarding which travelers are in the target market for the high-end trip cancellation insurance. Your manager has provided the following data dictionary and 10,000 records from selected columns of the survey data in a file called June 22nd data CSV. So you can see 10,000 samples is fairly large, which will allow for different types of machine learning models. And there are 1, 2, 3, 4, 5, 6, only 7 variables. However, we see that this reason is a category, and so this has several different levels. So potentially you could be creating a lot of dummy variables, as well as age. This is like numeric, but these are really binned values. So you can think of these as categories. So then the next part is the specific tasks. This is where the exam's a little bit different. The tasks are intended to be done in order with results from one task informing work in subsequent tasks. Graders will look for a solution to a given task only within that task's area in the report and where applicable in the RMD file. Additional info given below in italics and not indented applies for all tasks that follow the information and is labeled accordingly. Items that further explain a specific task are indented in plain text. So, in other words, this additional info for candidates doesn't just apply to this task here. This also applies to this task, and to this task, and to this task, and this task, and similarly, the info from here says additional info for candidates. This applies to task 3 and task 4. And task 5, so you can think of it as this cumulative increase where at each question they give you more info that applies to all of the subsequent questions. So, in addition to the National Travel Survey, your manager has asked your team to propose other data sets that may prove useful in your predictive modeling work. Your assistant has discovered the following data sets: A, B, C, D. Audio recordings from your customer service center, publicly available social media profiles and images of policyholders, demographic information on the policyholder, expected trip itinerary information for policyholders. Okay, from the following, classify each of the 4 data sources as structured, semi-structured, unstructured. Justify your classifications. So when I first looked at this, I was actually somewhat confused by some of these categories. The first one, audio recordings, that one's fairly straightforward. That would be audio recordings are unstructured because each file is in a like an MP3 in audio format and not in a table. There are no features, and so these would need to be extracted. So the question was really, if we're selling travel insurance to people and we have these other data sets lying around, is it worth putting in the work to try to make them useful? So I would say no. This data set would require significant work prior to modeling in order for the results to be useful. Okay, and then publicly available social media profiles and images. So if you think about like what a social media profile is, you'd have like name, age, location, and then like photos, like photos of people doing things on vacation, traveling, at restaurants, whatever. So this part would be structured because you could put that into a table, but then like photos and the bio and profile comments, those would be unstructured. So you could say social media profiles are semi-structured because the profile info such as name, location, and age are clearly defined and could be used as columns in a table. However, there are also unstructured data elements such as the photos, biography, and comments. So for the purpose of selling travel insurance, this data could be useful if it was available to all customers. Using publicly available media, it tends to be unreliable because anyone can choose to hide their information. Then you have C, demographic info. So demographic info is structured. Whether or not a person purchases insurance is dependent on their income level, age, experience traveling, and other characteristics. And then finally, expected trip itinerary info for policyholders. So itinerary data set would have like a person's name, their ticket number, and then the origin and the destination. Like if you're flying from New York to San Francisco or Boston to Chicago, you'd have like this type of itinerary, as well as like the specific flight that you're on, or the specific train. So this is also semi-structured. Because the geographic start and ending locations, as well as mode of transportation, such as flight, such as the flight number are not in a standard format. We would need to create columns using text for city and country information. Okay, and then the next part is assess for a general audience, your manager, the trade-offs of using each of the above data sources for this business problem. Your assessment should include considerations beyond the structure of the data, but shouldn't include one page. So you could format your answer in a few different ways. So let's format it like this. Let's say this is audio recordings. So if you're using audio recordings, what would be the advantages and disadvantages, or the pros and cons? Well, they're from your customer service call center, and remember, our goal is a Canadian travel insurance provider. So understanding our customer better by examining our phone calls could provide value. We may be able to discover what complaints customers have and then pass this info along to our customer service team. One disadvantage, though, is that the data is from existing customers, and so this effort would not help to acquire new customers. The next one, social media profiles. So social media, so Facebook or Google ads are a common way of attracting new customers. Using publicly available data, we could segment customers into different groups and then pass this on to marketing so that they could target their advertisements. And I know this might be a little bit more businessy than what the SOA expects. So you don't have to be that fancy. You could just say, like, social media could be useful for understanding our customers. One disadvantage, which we already talked about, was that wouldn't be available for all customers. Perhaps not everyone's on social media. Okay, demographic data set. Yeah, and also with social media, you also have potential ethical concerns. Is the potential ethical concerns around a person's race or other private information, whether this is legal to use for selling insurance. The same with this one. One major disadvantage is that private info would be in the calls, and we would need to take careful steps to address the ethical implications of using this data. And then, demographic info. This is the most general data set, and so would not have ethical concerns. Demographics are easy to acquire and do not change over time, which makes them stable for analytics. And then itinerary data set. This is well, it could be that people may purchase insurance more often in certain geographies or when traveling to certain countries. COVID did have travel restrictions and mask bans for some regions and not for others, and so including this info in the analysis would help us to explain why each customer chooses to purchase or not. And this has been somewhat of a long answer, and that's intentional. That's to give you more than you need. The answer said don't go over 1 page, and this answer is over 1 page. So the SOA said that quality responses to this question included the identification of different data types and the ability to communicate reasoning behind why certain data items may or may not be useful for the modeling problem. A majority of candidates were able to identify data sources as structured, semi-structured, or unstructured. Most candidates were able to identify reasons why or why not a certain data element would not be helpful, with the most popular response highlighting ethical concerns. Many candidates failed to recognize audio recordings had come from the claims process. Candidates failed to earn points if justification for a data source seemed boilerplate or was nonsensical. So when you're going through these answers, don't just copy the SOA's answer. Think of original ways of solving the problems. Additional info for task 2 and beyond. Before starting your modeling work, you asked your assistant to summarize the data. As part of this work, your assistant produced the following 4 graphs on a similar but larger data set. They're right here. Describe for a general audience, your manager, 3 specific conclusions from interpreting one or more of the graphs above. For each conclusion, identify the specific graph or combination of graphs that support it. Describe which features of the graph led to your conclusions. So on your report, I don't think that you can take screenshots, but what would be good is if you took a whole screenshot and pasted it into the report. But you don't need to do that because you will just have the project statement printed out in front of you. I think you will have a pen with you, and so you can sort of draw on the graph, and just for your own insight, like if I'm looking at this graph, I see 2 variables, age and total cost, and I see right away that there's this big increase here where this age is higher than these other values. So that tells these are older people, 5 and 6, so 55 and 65 plus, and this is cost of trips by length and age. So I would say to the manager, the upper left graph shows the total cost of trips across customers' age. Well, our goal is to sell as much insurance as possible, and so we should target our efforts on older people who spend more on travel. Ages 5 and 6 along the horizontal axis represent people of age 55, 65, and 65 above, respectively. Bars twice as high as younger people. The blue region shows that what percentage? This is like 1/3, 2/3, roughly 2/3 of these trips are on extended overnight stays where 2 or more days are spent traveling. Okay, and then let's look at this graph here. Yeah, this shows the percent breakdown of trip costs. So notice that this trend is kind of flat. So this tells you that for all ages, the percent of trip cost is equally distributed. In other words, people spend the same percentage on, 0-night trips or like day trips. So this is like 80% to 1%. So 20% of the trips are on day trips, right? That's like 20%. And then this is like 10% green, and then this is like 70%. The upper right graph proves that people spend the same average amount per day, regardless of how old they are. Short day trips comprise about 20% of total trip costs for all customers over the age of 2. What is 2? 2 is 25. The leftmost bar, where age is 1, represents people aged 18 to 25. This cohort of young people spend considerably more. They spend about 60, because this is 50, so 50, so this is halfway between 55 to 67, about 60%. So that's about 40, so the red region is about 40% of costs on one-day trips, as shown in the pink region. The height of the pink bar, which spans from 0.6 to 1, is an area of 0.4 or 40%. Okay, now let's look at this graph. The lower left graph shows the count of trips. I see the same trend as the top graph, where there's this, increase here for older retired people. So you'd say retired people, frequency of trips. Let's just say retired people travel more frequently, as well as spending more. The lower left graph shows a similar pattern to the upper left graph, because ages 5 and 6 have a total of about 10,000. See, 10,000, that's 5,000 times 2. Wait, how is that right? Because think about it, data has only 10,000 rows. If I look at the data, so if I look at the dimension of the data, I see that there are only 10,000 rows. And each row is like distance, duration, vacation, cost, and so forth. So this graph seems to be counting more people. This is a height of 5,000, so this is 5,000. So 5, 10, and then if you stack this graph on top of this graph on top of this graph, you might get another 5. So overall, it looks like it's 5, 10, 15, maybe 20 or 17,000. The total number of trips, as shown, appears to be 17,000. Which can be found by adding together the bars. The two rightmost bars are 5,000 each. The bar where age is 4, about 3,000, so forth. This is higher than the data set, which has only 10,000 observations. We need to be careful that we are not excluding important trips from our analysis. Yeah, I think that's actually a mistake in the exam, which does happen. If you do notice something like that on the exam, definitely comment on it, because in the past, when candidates have pointed out mistakes in the report, they have gotten a free pass on that question. Yeah, so that was the question. Notice 3, classify, assess for general audience and manager the trade-offs of using each of the data sources. Okay, no. Describe for general audience 3 specific conclusions from interpreting one or more of the graphs. For each conclusion, identify the specific graph or combination of graphs that support it and describe which features of the graphs led to your. And then the answer, quality responses to this question demonstrated knowledge of how to interpret graphical information. Candidates were able to find 2 conclusions but struggled for a third. Many candidates noted the discrepancy between the breakdown of trip costs and trip counts for the youngest age bracket. Yeah, so that's really looking at here. This amount. So younger people are spending more on day trips. Candidates didn't receive full credit if they provided 3 conclusions, but conclusions were restatements of one another. No candidates provided any rough mental math in the thoroughness presented in conclusion 3. Well, I think that what they're talking about is that in their model answer, they say, although 2 oldest groups take more trip counts and spend more money on trips, as noted, the average cost across all these lengths appears to not vary greatly by age group. The comparison of the top left graph supports this conclusion, though it is difficult to see visually, since it relies on comparing the ratios of lengths of bars to the top lengths of the corresponding bars at the bottom. So like, if you took all of this graph and divided by this graph, or the cost divided by the count, will get you the average cost. You could do the same thing if you're working with insurance claims, like claim costs versus claim counts would give you average claims. Still, since the height of the bars within each graph exhibit similar increases and decreases, moving from one age group to the next, it is fair to conclude that the average cost per trip is similar. Mental division of the top figures, the bottom figures suggested an average of 300 per trip when ignoring the number of nights. Yeah, 300 per trip, or 1.5 million on 5,000 trips for the oldest 2 groups in the right graph. Yeah, it's funny that they notice that it's 5,000 trips here, but they don't notice that their data only has 10,000 records. And finally, it's a good idea to write this specifically to the manager. Like the answer says, assess for a general audience your manager. Like just make it easier for the grader. So what I'm actually going to do is just make a copy of this and then say, I classified each of the data sources below, and then put this info, and then put like the first bullet point, and then I'll say underneath to the manager what the other info is. And then say to the manager, to sell travel insurance, to say to sell travel insurance, I assessed 4 data sources and provided a few trade-offs, provided several trade-offs for using each. And then I can even break up these bullet points, like Facebook. Break these up into separate bullet points like this. Additional info for task 2 and beyond. Before starting your modeling work, you asked your assistant to summarize the data. As part of this work, Your assistant produced the following 4 graphs on a similar but larger dataset. They're right here. Describe for a general audience, your manager, 3 specific conclusions from interpreting one or more of the graphs above. For each conclusion, identify the specific graph or combination of graphs that support it. Describe which features of the graph led to your conclusions. So on your report, I don't think that you can take screenshots. But what would be good is if you took a whole screenshot and pasted it into the report. But you don't need to do that because you will just have the project statement printed out in front of you. So I think you will have a pen with you, and so you can sort of draw on the graphs and just for your own insights. Like if I'm looking at this graph, I see 2 variables, age and total cost, and I see right away that there's this big increase here where this age is higher than these other values. So that tells me that these are older people, 5 and 6, so 55 and 65 plus, and this is cost of trips by length and age. So I would say do the manager. The upper left graph shows the total cost of trips across customers' age. Well, yeah, our goal is to sell as much insurance as possible, and so we should target our efforts on older people who travel more, who spend more on travel. Ages 5 and 6 along the horizontal axis represent people of age 55, 65, and 65 above, respectively. This is almost the bars twice as high as younger people. The blue region shows that what percentage. This is like 1/3, 2/3, roughly 2/3 of these trips are on extended overnight stays where 2 or more days are spent traveling. Okay, and then let's look at this graph. So we see here, we can look at, this one. This shows the percent breakdown of trip costs. So notice that this trend is kind of flat. So this tells you that for all ages, the percent of trip costs is equally distributed. In other words, people spend the same percentage on 0-night trips or like day trips. So this is like 80% to 1%. So 20% of the trips are on day trips. Right? That's like 20%. And then this is like 10% green, and this is like 70%. The upper right graph shows that people spend the same percentage on trips per day on average. Yeah, the upper right graph shows that people spend the same percentage on trips Just, yeah, the overgraph which it proves that people spend the same average amount per day across, regardless of how old they are. Short day trips comprise about 20% of total trip costs for all customers over the age of 2. What is 2? 2 is 25. Leftmost bar, where age is 1, represents people aged 18 to 25. And this demographic or population cohort, people, of young people, spend considerably more. They spend about 60%. This is 50. So 50. So this is halfway between 55, so 67, about 60%. So that's about 40. So the red region is about 40% of costs on 1-day trips, as shown in the pink region. The height of the pink bar, which spans from 0.6 to 1, is a area of 0.4 or 40%. Okay, now let's look at this graph. The lower left graph shows the count of trips by length. So this, I see the same trend as the top graph, where there's this, increase here for older retired people. So you'd say retired people, the frequency of trips for, let's just say, retired people travel more frequently, as well as spending more. The lower left graph shows a similar pattern to the upper left graph, where, because ages 5 and 6 have a total of about 10,000. See, 10,000, that's 5,000 times 2. Wait, how is that right? Because if you think about it, in this data set, the data has only 10,000 rows, right? If I look at the data, so if I look at the dimension of the data, I see that there are only 10,000 rows. And each row is like distance, duration, vacation, cost, and so forth. So this graph seems to be counting more people, right? Because just this is a height of 5,000, so this is 5,000. So 5, 10. Then if you stack this graph on top of this graph on top of this graph, you might get another 5. So overall, it looks like it's 5, 10, 15, maybe 20 or 17,000. The total number of trips, as shown, appears to be 17,000, which can be found by adding together the bars. The two rightmost bars are 5,000 each. The bar where age is 4, about 3,000, so forth. This is higher than the data set, which has only 10,000 observations. We need to be careful that we are using, not excluding important trips from our analysis. Yeah, I think that's actually a mistake in the exam, which does happen. If you do notice something like that on the exam, definitely comment on it, because in the past, when candidates have pointed out mistakes in the report, they have gotten a free pass on that question. Yeah, so that was the question. Notice 3, classify, assess for general audience and manager the trade-offs of using each of the data sources. This problem. Okay. Describe for general audience 3 specific conclusions from interpreting one or more of the graphs. For each conclusion, identify the specific graph or combination of graphs that support it and describe which features of the graphs led to your conclusion. And then the answer, quality responses to this question demonstrated knowledge of how to interpret graphical information. Candidates were able to find 2 conclusions but struggled for a third. Many candidates noted the discrepancy between the breakdown of trip costs and trip counts for the youngest age bracket. Yeah, so that's really looking at here, this amount. So younger people are spending more on day trips. Candidates didn't receive full credit if they provided 3 conclusions, but conclusions were restatements of one another. No candidates provided any rough mental math in the thoroughness presented in conclusion 3. Well, I think that what they're talking about is that in their model answer, they say, although 2 oldest groups take more trip counts and spend more money on trips, as noted, the average cost across all these lengths appears to not vary greatly by age group. The comparison of the top left graph supports this conclusion, though it is difficult to see visually, since it relies on comparing the ratios of lengths of bars to the top lengths of the corresponding bars at the bottom. So like, if you took all of this graph and divided by this graph, or the cost divided by the count, will get you the average cost. You could do the same thing if you're working with insurance claims, like claim costs versus claim counts would give you average claims. Still, since the height of the bars within each graph exhibit similar increases and decreases moving from one age group to the next, it is fair to conclude that the average cost per trip is similar. Mental division of the top figures and the bottom figures suggested an average of 300 per trip when ignoring the number of nights. Yeah, 300 per trip for 1.5 million on 5,000 trips for the oldest 2 groups in the right graph. Yeah, it's funny that they noticed that it's, 5,000 trips here, but they don't notice that their data only has 10,000 records. Additional info for task 3 and beyond. Your assistant continues to explore the data. When reviewing your assistant's work, you notice that the cost variable requires some attention before modeling proceeds. Your assistant's initial 2 graphs, which you can see if you run the code in the RMD file, depicting the variable do not fully reveal the issues with cost. You alter one of the graphs to get a better view, and then make a first edit to cost. Let's see. So, first edit. Right here. So there I see the graph. So there's the cost on the x-axis, a cost on the y-axis, duration on the x-axis, and yeah. So you alter one of the graphs to get a better view, and then make a first edit of cost. After creating a second graph, you also make a second edit on cost. You then produce a third and final graph that conveys some important features of cost. You meet with your assistant to discuss these graphs and edits, which are found in the RMD file. Okay. So there's the first graph, there's the second graph. So this first graph is just limiting the x-axis to 0 to 40 and the y-axis to 0 to 1500. And yeah. And it's making some edits and then redrawing these graphs. So at this point, remember that you have the data-viz cheats. These can help you to make the graphs easier to read. It will get you more points on your exam because you'll be able to show the grader that you really make full use of the ggplot library. Right here. First of all, critique your assistant's 2 graphs. Okay. So, first graph, let's copy this. After viewing the work from my assistant, I made these observations about the graphs. You don't have to say that exactly, just say like something like that. After looking at the graphs, these are my comments. This scatter plot could be improved in several ways. First of all, there's no title. And so improve this graph by add a title so that the audience can understand the purpose of the graph. Add that the data is actually filtering out some rows. So you, from 0 to 40 and 0 to 1500. And if you look at summary data raw, duration goes from 0 to 81. Cost goes from 0 to 61,000. Whereas this graph only goes to 15,000. Is it 61? And so this graph is not showing several points. How many points is it not showing? Well, the way to do that is to look at data. If you want to know how to filter out, well, you can just copy this code. So this is saying data cost less than 15, duration less than 30, like that. So if I take data, I'm just sort of copying this syntax. If you don't understand what I'm doing, you could also look at the cheat sheet for base R. And what you want to look at is selecting vector elements. Right here, so it's selecting a subset of the vectors given a condition, and also here matrix subsetting. That's what you're doing. You're looking at a subset of the rows given this condition. So look at data. Where cost less than 15. Actually, where cost is greater than 15. And where duration is greater than 40. Put all this in parentheses. It's all one big, this is a big true-false value. See, like that. So you're just selecting the rows where that condition is true. So do that raw cost greater than 15. And then you just want to look at number of rows. So you use n row of all this. Why is this not true? Okay, so there are 5 rows where this is greater than 40. There are 2 rows where that's true. Oh, does this have to be and? Oh, okay, I don't want this to be and, I want this to be or. If there are any rows that are outside of the graph here, so that are like, you know, way over here, or any points that are off here, that are outside of the graph, then they're not shown. And this tells me that there are 7 records. Got a caption which says that there are 7 trips which are not shown on the graph because they are outside of the axes. Right. And then add a comment in the RMD file to say what you're for edit 1 for graph 1. And then here's the second graph. Well, other things that you could note about this graph is that all these points lie on top of each other. So the way I would fix that is make the points transparent so that overlapping points can be, so that data density. Also, I don't know what type of regression line this is. You know, there are different types of lines. It could be weighted regression, unweighted regression. So clearly label the type of regression line which was used so that the blue line is not ambiguous as to weighted or unweighted least squares is used. Optionally, you could also add dollar signs to the y-axis. And then moving on to the second graph. That's here. So this graph leaves a lot to be desired. Y-axis label. This graph doesn't have a title. The y-axis has ambiguous units. The label is simply density. Does not convey what is being shown. So, you know, converting this to a count or using a histogram would make the graph easier to read. So if you look here on the DataViz cheat sheet, what you're looking at are these one variable graphs. So they're using data density. Well, not a dot plot, because that's if the x-axis is discrete, but a frequency polygon or a histogram, even a QQ plot, or this geom area. I would also add dollar format the x-axis to use dollar signs so that the audience understands the financial impact. And also, this is just a very long tail graph, so consider applying a log transform to correct for the right skewness in the graph and show the length of the tail in easier to read manner. Tail in an easier to read manner. Okay, there's your first edit. first of all, it just makes a copy of data raw, and then data 1 edit costs less than 15. So why does it do that? Justify your first edit. So I would justify that by looking at the quantile. So we're saying cost less than 15. And so that's the third quantile, 75% of the data is that. You could also look at quantile cost. See 75th percentile. This function, if you want to know exactly what percentile is that, well, you actually just need to look at the number of points that are greater than it. If we just look at data raw and row where data raw cost is greater than that, or rather, you want to look at the length of this. I'm sorry, the sum. The number of true values. There are only 2 values that are greater than 15. It says, run but do not change this code unless it results in an error. You know, it doesn't result in an error, and we're not changing this code. What we're doing is sort of just doing our own, like, detective work. So my assistant's first edit was to remove 2 observations where cost is above 15,000. Out of 10,000 observations in the data, this is justified, and then the next edit, then also they remove crossword diversions less than or equal to 30. This is 9 observations. 9. And so this is justified. This improves the graphs, and then the second graph is right here. So what do they want to do here? So for your second edit, discuss important features of cost as shown by the final graph. So your second graph, so is your first graph the first edit? Yeah, because it says don't make any changes to the code. So this graph adds the title and doesn't limit the x-axis. So yeah, I mean, that's confusing. The comment, the RMD file said not to make any changes to the code. And so I was not able to implement all of the changes which I suggested above. Here's that graph. The graph below fixes the error of the missing title and shows all of the points, including outliers, which shows that the regression line, fails to explain several points which have a low duration but a high cost. Yeah, I mean, they didn't fix the other things where I said, like, add dollar signs to the axis, add a caption that tells you how many points you're missing, format the clearly label the type of regression line. they didn't do those things right. And then the next one is here. So this graph below added a title. Cost goes from 0 to 60. 0 to 60, that was the same. Units on the y-axis, so the same. And then your third graph, they take cost and they add cost plus 1. And then they apply log transfer. The third graph fixes the issue of the earlier density plot by adding 1 to cost and then applying the log transform to correct for the skewness. 1 was added because the data contains cost values which are 0 and the logarithm fine for zeros. Let's just make sure. Including how the modeling implications of cost will vary for a decision tree or a generalized linear model, in which cost is the regression target variable. Yeah, so if using a GLM with cost as the target variable, then the response distribution will need to be right skewed, such as an inverse Gaussian or a gamma. For a decision tree, it makes predictions by taking the mean of all values in the terminal nodes, applying a log transform would potentially improve the model by correcting for skewness. The mean is sensitive to outlying values, so using a log of cost as the target corrects for skewness in the terminal nodes. And then the answer says, quality responses to this question demonstrated knowledge of how to properly display info in graphical form and how target variable transforms would affect the objective function in either a GLM or tree-based model. Most candidates were able to identify issues with the assistance graph as well as to justify the first and second edits. Candidates failed to earn points if they did not recognize adding 1 was used to make log transforms possible. Many candidates identified issues with the right skewed variable would have in a GLM, including selecting a right skewed distribution function. Many candidates failed to receive full credit because they did not recognize a right skewed variable would also impact the objective function of a decision tree, thus giving granularity to predictions in the right tail of the distribution, the part which the client is concerned. So this answer actually went above and beyond because we included more insights about ways of improving the graphs, which could only make your answer even better. Additional info for task 3 and beyond. Having benefited from your explanation, your assistant builds 2 regression trees that differ only by the form of the dependent variable, one using cost and the other using log 10 cost. The resulting tree, no code is given, are below. Your assistant is surprised by how different they are and is not sure which one to use. Just then, your manager stops by It wants to know more about what the interesting diagrams mean for the trip cancellation insurance product. So here are the two trees, some of the things. So perform the following. Writing for your general audience, your manager. Describe the important differences between the two trees and explain why they occur. Recommend which tree is preferable. Okay, so what are the things that are the same? Well, first of all, the height is 1, 2, 3. And the height here is 3. And then there are 1, 2, 3, 4, 5, 6, 7, 8 nodes. Okay. And it's the same shape, but otherwise these are completely different. You can see that the distance variable is different. Like this is using distance, this is using duration, this is using, duration. So the nodes are completely different. And then if you look at the values here, this value is the prediction. So 132, and this prediction is only 1.706. So this is using the cost, right? Because if you take like the log of like 100, it will be like somewhere like a small number. And then the percentages here are the distribution. So you can see that the distribution on the top tree is completely different than the distribution on the bottom tree. If you were to draw like a histogram of these, this would be like 50%, 15, 23, and then it's really small, like 2%, 1%, 5%. So it would be like this, and then just like flat. For this tree, it would be, like 25, 9, 25, 7, and then a little bit higher, like that, right? So there's a lot more density in this right side than this tree. So yeah, that's what it would. So to summarize, the two trees are very different. First tree uses the cost value, and the second uses the log of the cost plus 1, which results in a different structure. The first tree as you can notice, the first tree has different variables in the branches, which can be seen in the diagram. The outputs of the predictive model are different as well, because the first tree uses the numbers in the bubbles in blue, which are called the terminal nodes. Smaller are larger. The shape or the distribution of the outputs is wider, more spread towards higher cost trips in the second tree, which can be seen from the percentages shown. So for the purpose of making travel predictions, the second tree is more fitting because there are more values for expensive trips. Recommend which tree is preferable for informing the trip cancellation insurance product. Justify your recommendation. So I was somewhat skipping ahead because I had already read this question. We suggest that the second tree will be best for improving the profit of the trip cancellation, trip insurance product. The suggested tree to the adjust and more spread towards higher values in the second tree can be seen with the percentages shown. It's like the right, and then it's always good to do a little bit of mental math. Like the right 3 branches make up 14 plus 6, which is 20, plus 3 make up 23%. The 3 rightmost nodes total to 23%. Let's do 14% plus 6%, 3%. In the second tree, but only in the first tree, like 2% less than and 4%. So our goal. So for the purposes of making travel predictions, the second tree is more fitting because there are more values for expensive trips. Our goal is to distinguish high value customers who are, so it seems like these values are small, but if you take 10 to the 3 or 10 to the 3.2, that's like 10,000. If you take 10 to the 2.89, that's like 1,000. So these values are higher. Our goal is to distinguish high value customers. And if we apply the reverse log transform, then we can see that the second tree's predictions are about 100 to the third, or in the thousands. So the SOA's answer says, quality responses to this question demonstrated knowledge of how the objective function of decision trees interacts with right skewed target variables. Now remember from the cheat sheet that there are different ways that you can measure performance. Typically for a decision tree, it will minimize the root mean squared error, right? And this is sensitive to skewness. So if you input skewed data into this, the metric will still be skewed. And so if you apply the log transform prior to fitting the tree, you'll get completely different results than if you don't apply the log transform. Additional info for task 5 and beyond. Your manager is satisfied with your explanation and leaves. Your assistant, moving to another topic, is worried about highly correlated variables in the data and has built a correlation matrix for the numeric variables. Your assistant has also read about principal component analysis and decided to apply it. Task 5, 8 points. Explore correlations in PCA. After running and considering the code in the RMD file, assess the choices made by the assistant for both correlation matrix and PCA, including implications for predictive modeling work and practical advice for your assistant. Do not alter your assistant's work. Okay, so let's look. So first of all, your assistant has produced the code below. Run, but do not change this code unless it produces an error for some reason. So let's see, numeric calls, distance, duration, reason, age. Are these actually numeric? Distance, yes. So let's just, check that that makes sense. So the assistant's code first checked to verify that distance, duration, number of nights spent on trip, that's numeric. Reason, no, that's not. Age is true. Age is numeric, although it's in these bins. That each used was numeric. The distance, duration, age, and cost are numeric. However, it is worth noting that age uses a number uses an integer represent age bins, ranges. Okay, and then they say create the correlation matrix. There's the correlation matrix. So I always like to look at these in Excel. Open up Excel and then go to data, text to columns. Oh, it's already in text to columns. So now you just need to do home color scales. And then you can round these. I want to copy this and then copy this picture, which will allow me to make this nice picture. So this is using distance, age, others. Oh, others is also included. Yeah, so notice that the target is cost variable. The target variable is included, which is useful for telling us which variables are likely to be predictive. So, for example, distance and cost, as well as duration and cost, are highly correlated values of 57%, 55%, indicating that these are strong predictors. And then duration and distance correlated as well. And then these are, I'd say that they're correlated positively. And then like duration and age, these are weaker correlations. Have a weak negative of 12%. And notice that because, let's see what the answer says. Your assistant, moving to another topic, is worried about highly correlated variables in the data and has built a correlation matrix for the numeric variables. But why is the assistant worried? Well, which can be a problem. That can be a problem because if you use highly correlated variables in linear models, you result in a singular valued model matrix, which means that matrix doesn't have an inverse, and so the regression algorithm doesn't work. And then you get coefficients that are NA. This is also called multicollinearity problems, which results in multi-t problems because the model matrix does not have an inverse. The singular, the matrix, the data, the algorithm is unable to converge, which results in coefficients which are nonsense. The way to resolve this problem is to remove either distance or duration from the model. This is a problem with GLMs especially. For decision trees, the problem is mitigated because of the automatic variable selection which takes place. Okay, and then now let's see what they do for PCA. So there's PCA, and it's running on, edit 2 of the data, which I see is, the earlier data that removed the outliers, and it's centering and scaling. The code was set up correctly to perform centering and scaling of the variables prior to running PCA. This is essential because PCA looks at the linear combinations of variables, and if all of the variables are not on the scale of 0 and 1, then the algorithm fails. And the algorithm is biased towards high variance predictors. And then it looks at the rotations, the summary, the scree plots. So I don't need to include all of these in the report. So it's enough to just comment on them. So the results of a PCA agree with the correlation matrix. PCA, so I guess notice that this is using cost in the PCA, right? So that's a problem because that's our target variable. It has a problem. It contains the target variable. We are unable to use these principles in the model because doing so would leak the signal. Yeah, this is because PCA uses linear combinations of the original variables. This works by performing a matrix decomposition and transforming the data into a new set of vectors and corresponding. The principal resulting, the weights are called rotations, and the vectors are called principal components. Using cost as an input would result in using cost as an input and then using the PC vectors in the model would result in the cost variable being present as both a predictor and as the target. So it is worth noting though that the first principal component has large values for distance and duration, and we saw that those were correlated. So you can note that. We do note the first PC has large positive values of 0.57 and 0.56 for distance, duration, which agrees with the above correlation matrix, which shows these correlations. To make this, we would need to remove the cost and then rerun PCA. We would then be able to select to reduce the dimension by only selecting a few of the PCs in the model. Okay, so like, we can look at this scree plot here. That's kind of useless. The current does not provide meaningful value. Okay, let's look at what the answer says. Explain how PCA can be used to develop features in a supervised. Additional info for task 6 and beyond. After trying out PCA, your assistant does not understand how PCA, an unsupervised learning technique for dimension reduction, can be used to generate features for a supervised predictive model. The assistant wonders whether running a generalized linear model, GLM, with lasso regularization would be a preferable alternative for dimension reduction. Task 6, 8 points. Discuss dimension reduction techniques. Perform the following. Explain how PCA can be used to develop features for a supervised predictive model. Compare PCA and lasso regularization on both how they perform dimension reduction and their interpretability. So first of all, this is just called discuss on the question, which means that you don't need to write any code. So let's say PCA, principal component analysis. Now you just need to basically give the definition, and you can get the definition from our cheat sheet right here on page 12. Principal component analysis reduces the dimension, refactors correlated variables into uncorrelated versions. Each PC is a linear combination of the original variables. Scaling is applied beforehand. So principal component analysis, PCA, is a dimensionality reduction technique which transforms the variables into an orthogonal set of vectors called principal components along with a set of weighting terms known as, this can be used in a supervised model by taking the principal components, by using the principal components as features. Only a subset of the PCs can be used so that the dimension of the data is reduced. And then the next part was compare PCA and lasso regularization on both how they perform dimension reduction and their interpretability. So when we look at lasso, we know that this is a type of GLM, and it's right here under penalized regression. So we look at the lasso, we know that this removes variables, and it does that by using a penalty term, which is the log likelihood divided by n plus the sum of the absolute values of the coefficients. The lasso, also known as elastic net regression with an L1 penalty term, is a type of GLM. In an ordinary GLM, only the likelihood of the data, the likelihood of the response given the value of the target variable is used as an objective function. However, in a lasso, there is an additional term which is equal to the sum of the absolute values of the coefficients. This has the effect of setting coefficients equal to 0 and thereby removing them from the model. PCA is different from lasso because PCA is unsupervised, whereas lasso is supervised. The code for this problem or PCA is not meaningful because it contains the target variable, and unsupervised learning does not contain a target. If you look at the official answer, they say quality responses to this question demonstrated more detailed knowledge of PCA mechanics for feature generation, selection principle components for modeling, and how lasso regularization can shrink coefficients to 0. So other things that you could have talked about would be like the way that you select features in a lasso by looking at the plot of the lambda value against the size of the coefficients, or in the case of PCA, how you look at the percent variance explained against the number of principal components. And then many candidates failed to receive full credit as they did not provide a quality comparison of PCA and lasso and how they performed dimension reduction. Comparisons of PCA and lasso unrelated to dimension reduction did not receive credit. So like another thing that you could say is like PCA removes variables by the user looking at the graph of the percentage of variance explained and then selecting a subset of variables. Or to say we would use a lasso to reduce the dimension by examining a graph of the value of the penalty parameter lambda against the sizes of the coefficients, then finding the point along the x-axis where coefficients are 0. And you can look at some other examples of lasso to see how that gets done. Many candidates discuss interpretability of one or both models, but they failed to receive full credit as they didn't compare the interpretability of the models, i.e. they only included separate statements about which was difficult to interpret. Yeah, of course, when you do PCA, for PCA, the results are not interpretable because they are linear combinations of the variables. Lasso is easier to interpret because the model preserves the original variables. So remember that from PCA you had a rotation, right? So like these were the original variables, and then you basically rotate them by multiplying by a scalar and adding some term, which is a linear transformation. And so you get out principal component. That's a rotation of the original vectors. But for lasso, you still get the original variables. You just get a different subset of them. You don't have all the features. And so that means that you can do all the same interpretation that you do for a normal GLM. Additional info for tasks 7 and beyond. You and your assistant decide not to use any dimension reduction technique and agree to predict cost using a GLM. Your assistant focuses on the age variable and is considering 2 transformations to replace age. 1. Convert it to a factor variable with 6 levels. 2. Replace each value with the average age for each band. Task 7, 9 points. Consider 2 transformations of the age variable. Perform the following. No code is required. Describe how the GLM will differ between suggested methods. Explain the difference between two transformations in terms of bias and variance. Describe for each transformation one distinct advantage that has over the transformation besides relating to bias and variance. So to come up with an example of what they mean, here's the data set, and then here's the age variable. So method 1 is to come up with different, the factor method is to come up with different methods, like age 1, age 2, age 3, and I'll just copy and paste this over. And each of these is 0 or 1. So this is 1, age 6. This is 1, 5, 5, 5, etc., etc. And then all of these other values are zeros. And then the average age value, this is an alternative way of showing the age. It uses, this table. So you have age and value 1, 2, 3, 4, 5, 6, and it's the average of 19 and 24. This is the average of 25, 34. And then you add 9 to it. Or rather add 10 to it. Yeah, well, this is the average like that. And then the average age is VLOOKUP of this, right? That should be age 2. Not sure why that produces an error. Oh. So obviously you won't use Excel on the exam. This is just for illustrative purposes. But there you can see what the two, this column or this column. So obviously you won't use Excel in your real exam, but this is just for illustration purposes. The factor method uses all these dummies, and the average method uses just this one. So if you're using all of the dummy variables, you actually have 6 variables, so you can actually delete this one. Because if you know that if, like take this one, this row for example, these are all 0, and so you automatically know that it has to be an age 6. Right, so that's the base level, or the intercept term. So you only add 5 variables. So in the bias variance trade-off, you have more parameters, which is synonymous with higher variance. So the variance of the model would be higher. So the variance is the amount by which the model will change given different training data, or the expected loss from the model being too complex and sensitive to random noise. So when this increases, when you have more parameters, the predictions will be more exact. So this will be higher, but the bias will be lower. The bias is not being complex enough to capture a signal in the data, or the simplifying assumptions made by the model. On the other hand, if you use just a single variable, this average, then you have only one variable. And because you have only one variable, the bias will be higher because you don't have as many parameters to specifically match to the data. However, if this is lower, this is higher, then this will be lower because you don't have as many parameters, and this is higher because it's making more rounding, more simplifying assumptions. So in both cases, the irreducible error is the same. So the two suggested transformations of age will change the bias variance decomposition of the model's error terms. The factor variable method would add 4 variables to the model because there are 5 levels, not counting the base level and the original age. So this would increase the variance because of the additional parameters, and so the model would closely match what the age values in the training data. On the other hand, the average age value would lower the variance because there are fewer parameters and because averages tend to reduce variance. So yeah, this would be accomplished by setting all trips with age equal to 1 to 21.5. Trips with age equal to 2 with 29 to 29, and so forth. Then explain the difference between the two transformations in terms of bias and variance. That's what we said. So the first method would increase the variance but decrease the bias because of the additional parameters. So the model will closely match the age values in the training data. On the other hand, the average age value would be lower, would lower the variance because there are fewer. The average age would lower the variance because the averages tend to reduce the variance, but increase the bias because there are fewer parameters because the averages tend to reduce variance. This would be accomplished by setting all trips with age equal to that. Describe for each transformation one distinct advantage it has over the other transformation besides just relating to bias and variance. So if you use a lasso or any other dimension reduction technique, it will just remove some variables. So it might like remove age 2 and age 5 like that. And that means that you have discontinuous age values. The factor method would potentially be less interpretable if when a variable selection method is used. Non-continuous age values may be present if their age factor levels were removed. Also, decision tree splits which can use specific factors may have rules which use non-continuous values. For the average method, one advantage is that interpretability would potentially be easier with these scenarios because only a single coefficient, single variable would be used. And then responses to this question demonstrated knowledge of modeling impacts of transforming a predictor variable. Full credit was awarded for identifying binning based on average age would result in a predictor monotonically increasing or decreasing with age. What does that mean? That means that, as you increase age, what does monotonically increasing mean? It means that as you increase one, you increase the other, and here as you increase the age, you also increase the value. Binning would allow for non-linear impact of age. Oh yes, so also non-linear and also interaction effects. The factor method, well, if interaction effects occur so like if you're in a tree, you could have a split that's like age dummy 1 is equal to 2, right? That could be a split. Or age dummy 3 is equal to 1. Let's say that. Right? Like let's say you had a rule that was like this in a decision tree. You could also just have that same rule that would be like age in 1 or 2, right? So if you used a decision tree, you could have interaction between the variables regardless of which method that you used. Additional info for task 8 and beyond. Your manager returns having thought more about the regression trees shown earlier and wonders whether you should instead build a classification model that predicts whether the cost is at least 1,000. The manager is unsure about which will better help ABC understand the market for its trip cancellation insurance. This sounds like a difficult manager to work with. First, he tells you to train a different model, and then he changes his mind and tells you to do something completely different. And this is frustrating. When you're sitting for the exam, you'll just work and you'll work and you'll work, and then they might tell you to do something just to test your patience to see if you are reading the instructions. That's part of the difficulty of the question. So watch out for that. Task 8, 8 points. Consider two models and their respective targets. Discuss advantages and disadvantages for each of the two models above. A GLM with cost as the target variable or the classification model mentioned by your manager for informing marketing about potential buyers of the trip cancellation insurance product. Do not build either model. Aim for 1/2 page and do not write more than 1 page. So, first of all, how much do we have to write for this question? I think that's what you all want to know. So, 1/2 of a page, like if this is the first part of a page, a full page would be that. You don't have to write that much. You really just have to write 1/2 a page. So like, down to like there. So we're talking to the manager. So we want to know, we could certainly train a model which predicts whether the prepaid travel expenses are over 1,000 or not. This would be called a binary classifier because there are two outcomes, and the result is a class of either high cost or low cost. In terms of predictive power, there would be no advantage to using this or the regression model from earlier, which predicts the cost dollar value. This is because the data input and computing resources are the same. ABC wishes, let's just read back. What I will always try to do in these questions is read exactly what they wanted in the beginning to show that you really pay attention. So yeah, we are in a predictive modeling team in the marketing department to help the organization increase sales and profitability of their high-end product. So wishes to increase sales for their high-end product. And so the idea of predicting only high cost customers sounds appealing. However, we would accomplish a similar task by predicting the cost for you using regression and then passing this information along to marketing. They would then be able to filter the data or data based on the predicted cost value, right? So we could create different types of graphs that would highlight this and so forth. Yeah, he just chose the value. He just made up the number 1,000. The number of 1,000 is arbitrary because there is no data to support that this is the ideal statistical cutoff value. Let's look at the average cost, summary, data raw, and then look at cost. The average cost is 405. Is less 150. So this value seems high and would result in the majority of records being classified as low cost. So also just like think about the cheat sheet of like if you had a GLM, what are all the advantages? What are all the things that you do? It's a regression model. Usually the target has a specific distribution. And then you have, these different outputs. You choose AIC, BIC, you look at the residual plots. And then you can interpret, right? GLMs are easy to interpret. They can be easily deployed in a spreadsheet. They handle different response distributions. They're commonly used in insurance rate making. Well, so you could do that for either like regression model or a classification model like a logit. But so what they're really asking, what are the advantages of a classification versus the advantages of a regression model? A regression model allows for the dollars in costs to be related to the inputs of distance, what are the other duration, reason, age, others, and mode. And so marketing would be able to see how much profit is gained in air versus non-air or business versus leisure travel. They would be to see the age, the relationship between cost and age. And of course, whenever you answer these questions, try to be as unbiased as possible. So if you give the advantages for one, also give the disadvantages. Let the manager make the decision. A classification model would have a confusion matrix and would give us a probability or a percentage, which is easy to understand as the likelihood that a person spends over 1,000. Probabilities are used commonly as conversion percentages, rates, winning percentages, or other types of stats. Yeah, and so are easy to work with. Yeah, marketing may already be familiar with these. May find this format to be easier to work with, to be familiar. Okay, and now I think we're at about half a page. Yep. Let's look at the SOA's answer. Quality responses demonstrated the ability to relate modeling results to the business problem. We discussed that the classification model more directly addresses the potential buyers, where the GLM provided additional info that may inform which customers would buy the most expensive trips. Candidates failed to receive full credit when they compared advantages and disadvantages of the models themselves. So what they don't want to see is that you take, advantages of GLM versus advantages of decision trees. That's not what it's asking for. Additional info for task 9 and beyond. Having heard your analysis, your manager wants to move things along and decides that your models going forward should predict whether the cost is at least 1,000. Before leaving, your manager also lets you know that the legal department is uncomfortable with including age and asks you to remove it from your future models. Your assistant gets to work, naming the new variable high cost and running a logistic GLM on training data. The assistant notes that high cost is unbalanced, with slightly less than 10% of the observations being a positive instance, but assures you that the unbalanced target is not causing any problems in this case. However, because the model has over 90% accuracy and the AUC is 0.9, both excellent results. All right, so is that true? Are they just sort of pushing you forward without really looking at the data? Task 9, 5 points. So remember, only 5 points, so this should only take about 10 or 15 minutes. Explain the problem with imbalanced classes. After running the assistant's code, explain how fitting the unbalanced high cost has led to a poor model for informing marketing about the trip cancellation insurance product, despite the excellent accuracy in AUC. So this is really a debate between you and your manager and your assistant, because your assistant says these are both excellent results. The model's great. And this is saying no. This has led to a poor model. So let's look at the code. So you can see a lot of code here. Your assistant's code for running and analyzing the logistic GLM is below. Run but do not change this code unless an error results for some reason. Okay, so load the libraries, create a new data set with high cost target, and remove cost and age. Okay. The process below partitions the data set into 70-30 training testing mix. Okay, and then check the means. So if I just run this part, yeah, I can see that the mean is about 9% and 10%. And then create logistic GLM. And then there's the summary, right? So let's copy this. And you might notice that this format is funny because there are a lot of extra spaces when you copy this. That's actually a bug in the current version of Microsoft Word in RStudio. So in this case, you don't have to copy it. You can just say that you ran the code. So I ran the code from my assistant, and then noted the results. Okay, so I'm looking for anything here that's wrong. Like, I noticed that all of the p-values are okay. That's good. I see that the residuals have a mean that's slightly less than 0. So it looks like they're a little bit skewed left because the min is a little bit lower than the max. So it's not a symmetric residual distribution. AIC. And then also look just to see if the signs of the coefficients make sense. Like, distance is positive, I guess. So as you increase the distance of the trip, you increase the cost. That makes sense. As you increase the duration of the trip, that should increase. I'm not sure what reason visit is. And then others in mode plane. Reason visit is reason for the trip. Vacation, holiday, leisure, recreation. So if you look at data train, reasons vacation, right? So anyways, it's always a good idea to look at the coefficients and to do some snooping onto the model to see if there's anything really wrong with it. And it doesn't look like there is. Now let's look at the results. So the first confusion matrix I see is based on the training data. So I really don't even need to look at this. I'm sure it's fine. What I really care about is the testing data. So here's the testing data. Accuracy is high, 92%. But remember that only 10% of the records are high cost. So if you had a model that predicted that all values were low cost, that model would have an accuracy of 90%. So that's really not that great. Kappa is a value that's between 0 to 1. 1 is the best, and 0.47 is quite low. The sensitivity, that's the percentage, that's also very low. Specificity is high. Positive predicted value is 0.82. Yeah. Detection rate's only 4%. Detection prevalence is only 4%. And balanced accuracy, which is a better measure in this case than using the straight accuracy because you have imbalanced classes, is only 67%. So the accuracy seems good at 92%. However, because only about 10% of the trips are high cost, making a prediction that all trips were low cost would still yield an accuracy of 90%. So this metric is meaningless. The balanced accuracy, which adjusts for the imbalances of classes, is poor at only 67%. The kappa, which is between 0 and 1, is low at only 0.457. And then calculate the ROC and AUC curves. So train, ROC, test. The testing AUC of 0.9015 is fairly high. However, the purpose of the model is to sell travel insurance to high cost customers. So we do not place a high value on this metric. And then what does the answer say? Quality responses tend to be straightforward in demonstrating knowledge of imbalanced classes and their impact on specificity, sensitivity, accuracy, and AUC. They relate the impact in this instance on specificity to the business problem, marketing's desire to correctly identify those who will take the high-cost trip. Many candidates failed to receive full credit as they did not address the relation to the business problem. A few candidates failed to receive full credit as they discussed imbalanced data but did not explain imbalanced data leads to a poor fit. Oh, yeah, so this data set is imbalanced because there are far more low-cost trips, minority. Just remember, when you're talking to your assistant, you can use technical language. The minority class is far higher, more prevalent than the majority class. Because low-cost trips, the majority class, are far more prevalent than the minority class, than low-cost trips. This creates problems in modeling because there are not enough records of the minority class for the model to learn from. The result models will be effective at predicting only the minority. Specific steps need to be taken to address this problem. And then we'll say the accuracy seems to be good at 92.39%. However, because only, what percentage? Let's use the exact percentage. .2%. Because only 9.2% of trips are high cost, making a prediction all trips are high cost. Making a prediction of all trips low cost would still yield an accuracy of 90%. And so this metric is meaningless. The balanced accuracy, which adjusts for the imbalances of classes, is poor at only 0.67. Let's do percentages here just to make it consistent. So 67%. The kappa, which is between 0 and 1, is low at only 0.57. The testing AUC of 0.9015, let's also use a consistent number of significant digits. So here we're using 2 significant digits, 470. So this AUC is fairly high. However, the purpose of the model is to sell travel insurance to high-cost customers, and so we do not place a high value on this metric. You then discuss undersampling and oversampling for addressing the problem. Task 10, 5 points. Discuss undersampling and oversampling. Describe how undersampling and oversampling work to address the problem of imbalanced classes, including the impact these techniques have on predictions. So this is really only 5 points, so I don't want to spend a lot of time on it. So the solution to the imbalanced class problem lies in the way in which the data is pre-processed. Prior to training, we can adjust the frequency of the classes by either oversampling the minority class or undersampling the majority class. Oversampling works by repeatedly drawing samples from the minority class until there are an equal number each class, right? This is only done to the training data. The testing data does not get changed because this needs to reflect reality. Okay, and then undersampling works by taking fewer records from the majority class until there are an equal number of both classes. Additional info for task 11. After this discussion, you and your assistant decide to apply oversampling. Right when you are finishing up, your manager stops by again and is interested in the confusion matrix. Task 11, 14 points. Implement oversampling and explain the confusion matrix. Perform the following, being sure to include the relevant confusion matrices in your Word document. Explain why oversampling must be applied after splitting train and test data. So first of all, let's look at the code. Well, this part's just saying explain why it needs to be done before splitting train and test data. And remember that this is to my manager. Oh, actually, no. It says explain why oversampling must be applied. Implement oversampling, explain to a general audience. So that means that these first two bullet points are just to a technical audience. So oversampling must be done prior to splitting train and test sets to avoid leaking the signal. This is when information regarding the outcome, regarding the target variable, is included. Well, no, this is when information regarding the test data is included in the training data. Oversampling makes copies of the rows of the data for the minority class. And so there will be duplicated records, rows present. Yeah, let's just say oversampling makes copies of the rows of the minority class. And so if this is, and so if the test set is taken after creating these duplicates. Well, let's just say oversampling makes duplicates of the rows of the data of the minority class. And so if test data is taken after oversampling, taken afterwards, then there will be identical records in both the training and test data sets. The model will then memorize the values for the training and overfit. Splitting out the testing data first and then performing oversampling on only the training partition avoids this problem. And then, and say, additionally, our goal is to build a model which is predictive on new data, which is not oversampled. And then implement oversampling, compare for your system the most applicable confusion matrix metrics between the original and oversampled models. So if we look here in the code, it says no code changes are needed. Okay, the following provides code for oversampling the training data, leaving the rest to you. So oversampling code for train data. And this is really complicated. What does all of this mean? Well, just take a deep breath and press the run button. And of course, you run all chunks above if you need to. And it says the mean of train data over high cost is 0.5. So that means that it's made a copy of the data called train data over. You can see it has the same columns as before, but this one has a mean high cost of 0.5, which means that there's a balanced, there are balanced classes. I ran, the code was set up to oversample, and we verified that this was done correctly by looking at the mean, by checking that the mean of the high cost variable was 0.5. Next, we need to fit the data on this, fit the model on this data. So let's go back up to the part where we train the model. So here's a create logistic GLM, and then compute probabilities, look at the confusion matrix, AUC, etc. So we've got that info. Let's put that below. And then we only need the training part, so we can delete all this testing stuff. So we have GLM train. Let's rename this GLM train over. And then the data set is this data train over. We fit this GLM. See that it has the same variables. Of course, the AIC is different. And then let's create the probabilities, the predicted probabilities. So this is the train predicted over. Well, we don't need that. We only need the test probability over. And then we want to use this GLM with the original test data, and then test data over is there, and then this is using test prob, and then here the confusion matrix. We can delete the train confusion matrix, and then we just want the test confusion matrix. There it is, and then we'll just make sure that we use the right prediction. So there's test pred over, and then there's data test high cost, that's right, and then data test high cost test pred over, and then there's test ROC over, plot test ROC over. There it is. So then we can look at the accuracy. So see, the accuracy is 87, but the balanced accuracy is higher. It's 82. Whereas when you look back at this other one, balanced accuracy was only 0.67. So the most applicable confusion matrix metrics between the original and oversampled models. So let's create a little table. So we'll look at original data. Let's say before oversampling, after oversampling. And then we want to know like the accuracy or the balanced accuracy. The AUC. You could also look at the sensitivity. So before oversampling, this was and then AUC sensitivity, and after oversampling, let's just round these all to 4 digits. The confusion matrix metrics before and after doing this are below. The balanced accuracy takes into account the accuracy on both the high cost and low cost trips. Looking at the accuracy by itself is unreliable, because any model which predicted that all values were 0 would still have an accuracy of 0.9 of 90%. The balanced accuracy, we can even do this. We can insert columns to the right. Percentage improvement. And then, well, if this isn't an Excel table, if this was an Excel table, we could do that. And make this a percentage. The sensitivity is relevant to this problem because we need to make accurate predictions. We need to market insurance to high spenders. This increases by 117% after oversampling. The AUC on the test set decreases slightly as a trade-off. Start putting that into a nice format. So let's say our prediction, and then we need these values. So this is low cost, high cost, and then this is reference. So all that I'm doing is just copying this confusion matrix over here. And then let's add column totals and row totals, right? And then just make this look nicer. You're all actuaries, so you're good at doing this. The metrics that we care about are not accuracy. We don't prioritize that, remember. You could show kappa, but that's not very popular on PA. Neither are these. So just look at sensitivity, except, we're explaining this to a non-technical person. So sensitivity is the percent high cost trips predicted to be high cost. And then that is the percent of high cost trips, so actual high cost trips. So it's that over that, 76%. And then let's make that a percentage. And then the balanced accuracy. I'm not going to create a formula for that. I'm just going to copy that. That's 82. Yeah, and then there are different ways that you could format this. One way is to just show that these are good values, and that these are bad because they're red. The metric that you really care about is this percentage here, so I'll make this bold. Okay, and then AUC. How do you interpret AUC? Well, you look on our cheat sheet and look under AUC. You can interpret this as the probability that a randomly chosen positive class is ranked higher than a randomly chosen negative class, or describes how accurate the ranking of the probability of purchase from highest to lowest is when compared with purchases made. So you could say think this is a good explanation for our case. So you could say this is describes how accurate the ranking of the probability of high cost is from highest to lowest when compared to, so that's AUC. Yeah. AUC describes. Okay, now just kind of put this in. So the final model can help marketing to improve profitability by segmenting customers who are likely to spend over from those who are not. Below is a way of measuring this effectiveness, known as a confusion matrix. The used formed a blind holdout strategy where 30% of the trips 2996 were kept separate from the analysis and only used to create this table. This helps us to ensure that the results will generalize to new trips which are booked. Yeah. So the green boxes are where the model is correct, and the red boxes are where the model is incorrect. We prioritize the high cost trips and see that 76% of the trips are correctly predicted to be. The balanced accuracy tells us that on average the 82% accuracy is 82%, which is great, which is excellent. This tells us that the model is doing a good job overall. The area under the curve, another common metric, is the area under the ROC curve, AUC, which describes how accurate the ranking of the probability of high cost is from highest to lowest when compared to trips booked. This is a 91.06, 0.91 out of 1. Let's look again at the question. Explain why oversampling must be applied after testing and training. Check. Implement oversampling and compare for your system the most applicable confusion metrics between the original and oversampled models. I have to go back to the original. So accuracy, well, that's not relevant. Accuracy isn't relevant. Sensitivity. Specificity. And then train, we don't really, yeah, test a, yeah, and then test metrics after oversampling. We actually don't really care about specificity. I think balanced accuracy. Balanced accuracy. The metrics, a comparison of the metrics from the confusion matrix is below. We choose to look at the sensitivity because this is the percentage of high cost claims, trips. And we know that only these trips will consider purchasing travel insurance. Similarly, the balanced accuracy is a better metric than the accuracy because there is an adjustment made for the class imbalance. The sensitivity increases from 0.35 to 0.76. The improves, actually, balanced accuracy, that's not right, it's at 0.67. That makes more sense. 0.67 to 0.82. The AUC, that's why the AUC is wrong. All three of these metrics are range from 0 to 1, where 1 is the highest. Okay, let's see. Yep, so we explain these metrics. Explain for a general audience, your manager, both the confusion matrix and the most applicable metrics for the business problem using only the results from the oversampled model. So that's what I've done already. AUC, balanced accuracy. Describe for a general audience, your manager, what additional information from the marketing department would help you and your assistant refine the model, perhaps with a different cutoff value than 1/2. Describe for a general audience, your manager, what additional information from the marketing department would help you and your assistant refine the model, perhaps with a different cutoff value than 1/2. Yeah, we can further refine. So in conclusion, we can further refine this analysis if we have more information about the expenses. We know that these are prepaid travel expenses, but have no information about the costs, about what marketing will do with that, do with the information. There are 75 trips which were incorrectly predicted to be low cost while they were high cost And so this represents missed opportunities for sales. These customers may be worth reaching out to, and we could change the model, the cutoff value, so that more of them are included as being predicted to be high cost. On the other hand, there were 312 trips where the model predicted that they were high cost while they were low cost. So if you predict that something's high cost while they're actually low cost, this group of people represents those who marketing would reach out to or send ads to, incurring an expense in the process, only to later discover that they are not eligible for the insurance. If marketing can provide us with the costs which they would incur for these types of mistakes, then we can optimize the model cutoff for profitability. And now make sure that there are no grammatical mistakes. So I just look at these blue items in Microsoft Word and make those changes.